working very hard designing a boat to win the Solar Splash 2018. On this presentation, we will be covering the topics on which the team will be working for the Solar Splash 2018 in Ohio. The Solar Splash is an intercollegiate solar electric boating competition which puts to the test electric boats from different colleges around the world. Mainly, the competition consists of 3 events: Endurance, which is the boat that does the most laps in 2 hours; Sprint, which is the fastest boat to complete a 300-meter straight line; and Slalom, which is the fastest boat to complete an 8-shaped lap. Here are the results from last year's competition. Last year's system allowed us to read the motor's RPM, boat speed, as well as motor and battery voltage and current. The system was based around the Lapjack T7 Pro. This device has a 16-bit analog to digital converter, which is necessary for reading currents and voltages. Another advantage of this platform is its ability to store values, along with wireless capabilities, which allow us to communicate with the Lapjack's internal memory. One of this platform's limitations was that the only way to program the Lapjack for it to run independently was in Lua, and this added a problem of a memory buffer getting full, stopping the Lapjack from storing values. Also, it does not allow for simultaneous wireless communication and internal memory storage. To improve upon this design, we are considering the possibility of using a different microcontroller or pair the existing Lapjack with a Raspberry Pi. This in turn will allow us to store and read values wirelessly and have a larger range for communication. We developed a signal conditioning PCB in order to read certain variables such as RPM, speed, currents, and voltages. Although the circuit was successful in attaining most variables, some, such as RPM, are not being read properly, as interference caused by the switching RPM sensor damaged some signals. Promptly, a new PCB will be designed fixing these issues. After a pause from working in hydrofoils like we did on earlier years, we are considering retaking a hydrofoil design for this year. This will allow us to increase efficiency and speed by reducing drag. The control system needed on our hydrofoils will work by receiving different state variables from different sensors, such as an ultrasonic sensor, speed, RPM, and a position sensor. The state variables are boat's height, velocity in 3 axes, rotation in 3 axes, and rotational velocity in 3 axes. The acquired values from these sensors are then used to calculate the position for the hydrofoil's actuators. Self-piercing hydrofoils are to be implemented on the boat. We are currently in the design stage with regards to the geometry of the foil. We will be testing our theoretical design with the prototype before implementing the final foils. For last year's competition, the team decided to build the solar panels themselves, gaining an extra 10% power allowance given by the competition for the extra effort. An analysis was made that concluded that our boat would receive more power from the solar panels if we reject this 10% power allowance, and instead, we opt for the store-bought solar panels with water cooling system. We used the manufacturer's parameters to create a discharge model for several batteries. We found a combination of batteries that will provide an increment of 70 watts, which translates into about 3 more laps on the endurance race. We hope you have enjoyed this presentation, and remember to follow us on our road to Solar Splash 2018 via our social media.